but overall it's a pretty cool video, so check it out.
Earlier this year, Reddit user CS-NL posted this question to the internet. Reddit, my friends call me a scumbag because I automate my work when I was hired to do it manually. Am I? CSNL was hired to do manual data verification and fixing on this gigantic Excel table, rows and rows of it. He was hired in this department of a bunch of people whose job it was for 8 hours a day, 5 days a week, to just do this to a giant Excel table. And they were pretty good at it. The typical daily output was 6 to 10 records a day with about 90% accuracy. Now, CSNL knew some basic programming, so he wrote a computer script to literally do his entire job for him. The script that he wrote completed over 1,000 records a day with 99.7% accuracy. He replaced an entire department in a weekend of coding. Now, I know what you're thinking. All right, smart kid, stupid company, they should have just hired a programmer in the first place because this data manipulation thing is what computers were designed to do. But I want you to think for a moment about the place where you work. And I want you to think about what it is that most people are doing there when they're working. Chances are, it's probably a form of data manipulation, and it looks a lot like this. And this, if it hasn't already happened, I don't know what it is that you do. It probably will happen soon. This has already happened to architects and doctors and even things that aren't even remotely related to computers at first, like painting. And in some cases, computers have completely replaced the person entirely. Did you know we used to hire people to stand in the middle of intersections and direct traffic? We used to hire people to print out yesterday's news and hand deliver it to us to our homes. We used to have stores that you could go to borrow analog copies of movies and rent them out, and they would charge you late fees if you didn't return them in time. Ridiculous. Like, what? And there are still a lot of societal problems that we're facing that don't make sense in a world with computers, like textbooks, really heavy books you can't search through, they're not linked to other things, or paper forms that people just retype into a computer, or classrooms. Why should I go to a classroom when I can watch a video on YouTube and I can fast forward through the boring parts and rewind through the other parts? There's a lot of problems like this in society that don't make sense in a world with computers. But what can you do about it? Well, to answer this question, I would like to travel back in time to the year 1961, the year we decided to put a man in a giant can and send him from Earth to the moon. But we had a problem. The amount of calculations you would have to do to coordinate this incredibly complicated rocket system to actually get you there and into the right orbits was way too much to do by hand. But NASA engineers were very smart. They built one of the most advanced computers of its day, the Apollo Guidance Computer, to do these calculations for them. They did that with this. How many people in this room have one of these? How many people don't? Like one guy in the back? Your cell phone in your pocket right now has the computing power to do the calculations for 1 million Apollo 11s simultaneously. Now, I couldn't fit 1 million Apollo 11 little graphics on this slide, but if you can imagine this slide repeated this many times, and then this slide repeated this many times, that's how many Apollo 11s your cell phone can do the calculations for. NASA scientists in 1961 would have fallen to their knees and worshipped you like a god for having this kind of technology. And what are you using it to do? There's a disconnect between the technology that you have available to you, the problems that we're facing in society, and what you know how to use that technology to do. So with this in mind, I've come up with a clear call to action, which is that you should learn to program. Now, there's a lot of studies that say that if you repeat something, you're more likely to remember it. So if on the count of 3, I could get everybody to say, I should learn to program. 1, 2, 3. I should learn to program. But why? Why should you do this thing you just agreed to? Well, I have 3 reasons why. Number 1 is that programming literally makes you smarter. What you're probably thinking to yourself is, why should I learn to program? Why did I just say that? Which is a good question, but it's probably also what people were saying in the 1940s about, in the 1400s about reading. And now that you know how to read, don't you think it's really convenient that you don't have to rely on someone else to do all of your reading for you? It's really handy that you're able to have this mental process, this mental tool that you can use to extend what you were otherwise currently capable of, to apply it to other problems. And computers are really good tools for extending what you're capable of. If a computer scientist, if someone with a little bit of programming experience has a problem of not wanting to go to the video store, they can make a website that streams video straight to your computer. If people are having problems with textbooks and a programmer says, oh, I have an idea, I'll make a website where everyone can edit it and it's immediately available to everyone online, they can do this. If someone doesn't like asking people if they're single, they can make a website that just lists that for all of their friends. A common side effect of solving these kinds of problems as a programmer is that sometimes you become a multi-billionaire. But even if you don't invent the next Facebook, knowing the basics of programming is really good for your basic fundamental tools of thinking, like being able to break up a really big problem into really tiny pieces, or being able to iterate over something really quickly and make small incremental changes, or being able to find a little tiny problem in a big, complicated system. Even, if nothing else, you'll know enough about computers to stop listening to what a talking paperclip is telling you to do and to start actually understanding how the computer's working. They didn't get this joke at TEDx Kids. We're getting old. But most importantly, learning how to program will let you use your computer's full potential. And this is only going to become more true as computers get faster and cheaper. Which brings me to my second point, which is that computers are getting better faster than you are. There's this law in computer science called Moore's Law that predicts that every 2 years, processing capacity of the average computer will double every 2 years. How much smarter does your brain get every 2 years? You're still much smarter than a computer, but for how much longer? The futurist Ray Kurzweil estimates that by 2025, you will be able to buy a computer with the computing capabilities of a human brain for $1,000. But even more amazing than that is what you can buy today. This is the Raspberry Pi credit card-sized computer. It started shipping earlier this year for $25. $25 for a computer. What? Imagine the things you could do with this if you knew what to do with this. $25, you could plug one into every washing machine and have it text you when your laundry was done, or plug it into every toilet in your house and congratulate you for peeing for a really long time. I did that. It was really fun. But you wouldn't know what to do with it if I gave it to you, because this is what it looks like when you turn it on. Which brings me to my third and final point, which is that you're lazy. But what you don't realize is that computer programmers are some of the laziest people on the planet. If there's a job that a computer scientist has to do that takes 10 seconds every day, a computer scientist will spend months making a tool for himself that can shave 5 seconds off of that. But when you're first learning how to program, it's going to seem like a complete waste of time. You're going to be learning things like how to get the computer to do math for you and how to get the computer to type out words for you. Things that would be much easier if you just did them yourself. But if you stick at it, if you can program for an hour a day, after about a month, you will reach this magical point where it's actually faster for you to program the solution to a problem than it is for you to do it yourself. And all of a sudden, life will just be magical. If you have a problem that used to take you hours or days, you can code up a solution in minutes. You will have this enormous capability of processing vast amounts of data and extending what you're otherwise currently capable of to solve these huge problems. You'll have the complete freedom to code up solutions that have never existed before with no one telling you that you can't, and you will feel inspired to become a programmer. Don't. I want you to go back to whatever it was that you were doing before you started to learn how to program, and I want you to bring back these tools that you've got from programming and apply it to that. I want you to rethink how people are currently doing what you're doing. There's a lot of people in the world that can program, but there's none that can also do what you know how to do. Now, how do you get started? Well, Google. Just Google how to program online. There's a ton of free resources. If you don't like any of those, I made a list on my website of some of my favorite ones. It's my name, christianjenko.com, and you can start learning. I'd like to close now with one of my favorite quotes from someone that totally would have been a programmer if computers had existed when he was alive. Henry Ford once said, "If you have a difficult task to do, give it to a lazy man, and he will find an easier way to do it."
So, that's the idea. I hope that gave you some motivation. I know some of it's kind of weird, what he was saying. But the main parts that I wanted to have you guys hear was the disconnect between the technology that's available to everyone and your average person's ability to manipulate this technology. So hopefully that kind of hit home. I also wanted you guys to hear about Moore's Law, which is referred to a lot in computer science, and it's the doubling of computing power every year. Now, it's not an exact law per se, but it's pretty accurate. And that should kind of turn a light bulb on in your head that says, well, if computers are so powerful now and it's so important to be able to program now, imagine how powerful it's going to be in 20 years or however long. So that's another really interesting thing. And yeah, so it's a decent video, and I just kind of wanted to give you guys a little bit more motivation, even though you guys are already learning how to program. So obviously, you guys already kind of get it. So now let's get into the PowerPoint. Let's see. Okay. Here we go. All right, so we've learned a bunch of stuff so far, and a bunch of really important things, and I'm sure that you guys don't necessarily completely understand it yet, and that's totally fine, because I put a bunch of stuff out there at first so we could have a bunch of knowledge to base other things off of, but it's going to take us a few weeks to get a really deep understanding of these things. Therefore, this week we're going to kind of just reiterate over what we've already done and hopefully solidify our knowledge, which should be good. Okay. Nice. Come on. Yeah, okay. Okay, so let's go over the general concepts that we've learned so far. So we've learned about variables, which are placeholders for value. So these are essentially names or words that you define, and then you're able to refer to these words to refer to a value. And I think we all have a decent understanding of that so far. And then we've talked about methods, which is a set of code with a name that you can call in order to execute that code. And these are really effective, and we've written a bunch in lab already. What's the next thing? Class. Okay, so we talked about classes. And these are molds for objects. These are the files that we write into, right, in Java? Or in Eclipse, rather. And yeah. And then we talked about object instances, which are the realization of the classes. They're the actual variables which you create, which hold the value of the class that you're then able to call methods on and to actually use. And then we also talked about if statements, which are a little bit different, but it's another tool that we've encountered so far. And it allows us to change the flow of our program depending on a Boolean condition, just like the word if in English. So that's kind of a general overview of what we learned so far. Now let's kind of do a little bit of a review of each of these things. So variables. Okay, so every variable has a type, name, and a value. You guys have heard this many times so far, but just keep hammering it in there. So the type and name don't change. As soon as you create a variable, that variable is always going to have the same type and the same name. But the value can be reset and redefined throughout the program as many times as you want. Okay, so here's an example of a variable declaration and definition. We're saying we want a new variable of type int with name size and a value of 5. So we've seen this line many times. We've written something similar to this many times, but that's the idea. And here's another example of a variable. It's a little bit different, right? So we've got a variable of type ball, name my ball, and the value is this new object instance, right? New instance of a ball, new instance of our ball class. So, yeah. So that's the idea with variables, right? Does everyone kind of understand variables so far? This is really one of the basic tool, and they're just used throughout programming, regardless of language. And yeah, so not too complicated, but it does take a little bit to wrap your head around. Again, the types, names won't change. The value can reset, be redefined throughout the program as many times as you want. And that goes for variables that aren't just primitive data type variables either. Even variables that are of a class type, like ball, they can be reset to a new ball later on. So that's the idea. Now, here's something that's been a bit of a stumbling point so far. There's two kinds of variables, instance variables and local variables. And they both accomplish a similar thing, but they have different properties. So let's go into a side-by-side comparison. So local variables are declared and defined within a method. So within the opening curly brace and closing curly brace of a method, a local variable is declared and defined. And they can't be accessed outside of this method that they are created in. So this is the key limitation of a local variable. So let's kind of see that limitation in action. So here we go. We've got a class called tire, and in our constructor method of the class right here, we're declaring and defining a new variable of type int, name radius, and value 40. Now, this is a local variable. Well, how do we know it's a local variable? Because it's being declared and defined within a method, right? Within the constructor of this class. So what's going to happen down here when we try to access the local variable that we created up here in this new method? We're going to get an error, right? This isn't allowed. Just like it says up here, we can't access our local variables outside of the method that they're created in. Does everyone kind of see this? So our local variable up here, radius, we've declared, we've defined. It lives inside this constructor method. You can modify it down here, you can access it down here within this method, but as soon as you get out of that method, it's like that variable just doesn't even exist. You can't refer to it as radius. Java's just going to say, I have no idea what you're talking about down here. I don't know that there's no variable called radius in this method. So that's the limitation of local variables. Does everyone see that? Now, in order to combat this and to present a variable that can be accessed throughout a whole class regardless of the method that you're writing in, we have instance variables. Now, Mo? Out of battery? Oh, interesting. Must just be having a hard time. Okay. So instance variables are declared outside of any methods. So they're not declared inside a method, but they are still declared within a class. So it's within the opening curly brace and the closing curly brace of a class. And therefore, they can be accessed anywhere within this class, within any method. And they use the private keyword in front of them, and they should typically start with an underscore. So here's our other example, which outlines instance variables. So here we go. We've got a similar, or we got the same name. We've got a new class over here that we're creating. Class named tire. Here we are inside our class, and right here we're declaring and defining our instance variable. And so the key differences here is we've got the private keyword, we've got the underscore here, which is a stylistic thing, and we've got our new instance variable name underscore radius type int. And here's our constructor. We give it a value, we define it, so underscore radius gets 40. And then down here in our next method, we return underscore radius. Is this going to be a problem? Yeah, it's not a problem at all. It's totally fine. So because we have an instance variable up here, which is declared outside of any methods, but still within our class, right up here, then we're able to access it anywhere. So we're able to access it down here as a return variable, or a return value rather, and we're able to access it here to give it a new value, So all that's totally fine. That Java says that's totally fine. I understand what underscore radius is, and you feel free to use it wherever you want. Yeah.
So why would you use local variables?
Yeah, okay, that's a great question. So you're probably saying just make everything an instance variable so you don't have any problems accessing anything. Well, you can. You can, but for a few reasons. Basically, variables aren't free. So the variable value is going to take up some memory, right, in your machine. So basically, you don't want to be using up a bunch of memory when you don't necessarily need to. Yeah, so it's inefficient, right? But if you don't have to worry about efficiency too much when you're starting out because computers are so fast and have so much memory now that it's not really like an issue until you start writing really complex programs. And also another reason is sometimes you want your variables to reset value every time a method is done. For instance, if you wanted like a counter variable that counted how many times something was done within a method, you'd want that to reset to 0 every time, right? Which you could do explicitly with an instance variable, but it's just a little bit more complicated and a little bit more bug prone. But that's a really good question because you're saying, well, okay, instance variables are basically just better, so let's just use them all the time. Well, you can, but it's a little bit of there's some limitations basically. But good thinking. All right. So can everyone pretty much see the distinction here between instance variables and local variables? And how they're created and how they can be used? All right, cool. So let's do some review on methods. So methods, like we said, are a block of code that you can call upon by name to execute. So you don't have to write the same lines over and over and over again in your program. And methods look like this, right? So we've got our method declaration here in this line up here. So public, double, average, and then we've got our open parenthesis, our two parameters, our open curly brace, and our closing curly brace that declares that we want a new method with all these characteristics. And so we have to know exactly what these characteristics are. So we've got a modifier, which is going to be public. For all our methods right now, we're going to be writing public methods. And that pertains to which classes are able to see this method. And public means everyone can see it. And that's what we want for our methods right now. So when you're writing a method, just put public first, and then we'll have our return type second. So this defines what type of variable we're going to be returning. Now, if you can look down here, we're returning average, the average variable. And it's defined and declared up here on the line above. And we can see it's got a type double, right? So that fulfills the return type of double. So return types, this is something that's kind of unique to Java. It's really strict. Some languages don't require it, but it actually is nice because now you know when you've declared your method that you're going to eventually want to output or return a double. So it kind of helps you organize your coding. And then we've got our method name, which can be anything you want, but you probably want it to describe what the method's actually going to do. And then we've got our two parameters, which are our input. And this is another somewhat of a confusing concept, but basically this makes it so you can have generalized input. So now you can average two general numbers, non-specific numbers. So this method is now extendable to averaging any two numbers you want, rather than averaging two specific numbers. That's why parameters are really powerful. And then down here, in between the open curly brace and the closing curly brace is the definition of our method, and that defines what exactly the method is doing. So in this instance, it's adding the parameters, storing it in a variable, dividing this variable by 2, storing that in a new variable called average, and then returning that average out to whoever called the method. So that's the output. So that's the idea. Yeah. So always public for now, and you can have as many parameters as you want, including no parameters if you don't need them. If you don't need any input, that's totally fine. You just have an open parenthesis immediately followed by a closing or closed parenthesis. And here's something we got into a little bit last week during lab that was a little confusing. So use a return type of void if your method is not going to return anything. So if you don't need to return or output anything, then you can just put void right here. instead of any return type. So let's see an example of that. Or first off, does everyone kind of understand the general structure of declaring and defining a method? We've done it a bunch in lab, but still it's good to kind of keep this going and keep thinking about it. So, good. So here's an example of a method with a void return type. So if you don't need to return anything or output anything, you're just going to do whatever you need to do and then stop the method and go back to whatever you were doing before. You can use void as a return type. So it looks like this. So this is a method, a new method, right? Can everyone see this? We've got modifier public, like always, and then here's our new thing, return type void. So this means we're not going to return any values from this function. We're not going to output anything. We're just going to do something else. And we've got a name greeting. We've got one parameter, one input here, which is a Boolean called ismail. And can anyone see what this method is doing? Yeah. Right, yeah. So based on whether or not ismail is true or false, if it's true, we're going to print out hello, sir. And if it's false, we're going to print out hello, ma'am. Right? So there's no need for an output here. There's no need for a return value because we're not producing any output. We're just simply displaying something to the console. So we don't even have a return statement here. There's no return X or return whatever. And that's totally fine because up here we've said, basically, hey Java, we're not going to be returning anything from this method, so don't expect a return statement here. So it's fine. No errors. It's a great method. Okay, yeah, does everyone see that? See what void's all about? Okay. So then another thing we've talked about and dealt with is the main method. So this is like the special method in Java. It looks exactly like this every single time. Whenever you see public static void main string, square brackets, args, this is the main method. And the special thing about the main method is where your program is going to start. This is where your program kicks off. And you basically have one main method per program, and not every class in your program needs a main method, only one. And it's going to look like this every single time. So that's just something you have to remember. So that's the main method. And okay. Now let's get into classes. So like we said before, classes are the mold for our object instances. So it's what defines how our objects are going to eventually behave and what properties they're going to have and what they're going to be able to do. But it doesn't actually produce any objects for us. And classes are made up of two things that we already know, two things that we just went over. They're made up of instance variables, which model the properties of our class, and they're made up of methods, which model the abilities of our class. So we've all seen these before in lab. We've written a few classes so far, and let's look at an example. Let's go back to our ball example. Okay. So when you're writing a class, or actually in Eclipse, it kind of does this for you because you select new class and you type in the name to the box, and it gives you this declaration automatically. But this is your class declaration. So it's basically saying to Java, I want a new class with the name ball, and then I have my open curly brace and my closing curly brace, and then between these two things is going to be the definition of my class. So this is the first thing that you do when you're writing a new class, although Eclipse basically already does it for you. And then the second thing that you want to do when you're writing a class is declare your instance variables. So declare your properties, right? So in this case, we're going to declare these three properties right here. We're going to declare a size, a color, and a bounciness. This is something we've done before, so I might be getting a little bit tired, but just to make sure that we're getting it, we're going to go over it one more time. So first thing you do, or second thing rather, after you have your declaration, is you want to create your instance variables. You want to create your properties. So that's step number 2. Step number 3 is going to be to create our constructor method, okay? So this is the special method that every class has, and it has no return type, not even void. It's just public, space, and then it's got to have the same exact name as the name of your class. And other than that, it's just like any other method. You can do whatever you want inside. You can have parameters. And it's going to be called on the creation of a new instance of your class. So that's the third thing you want to do. So you want to create a new class. First thing you do, declaration. Second thing, create your instance variables. Third thing, write your constructor. And your constructor very often will define the value of your instance variables. That's like a typical thing to do within your constructor method. And then the fourth thing you want to do is write any other methods you want to write. So you can write as many or as few as you want. And you don't have to get everything perfect right off the bat. You can go back and change it, obviously, or write new methods, or create more instance variables, or modify your constructor. But that's the general workflow of creating a class. So you declare your class, declare your instance variables, write your constructor, and then you write all the other methods that you want, and then boom, you have a class. You have a class that does whatever you want it to do, as long as you didn't make a ton of mistakes, which you may have, and then you just have to go back and fix them. So that's classes. So does everyone kind of see what classes are all about? Mold for an object. We've all written them. I'm not sure if we've all totally understand how they work. I'm not sure if we do even now, but we will eventually. Okay. Next thing is object instances. So this is the realization of the mold. This is using the mold to create something that you can actually use, an object instance. So you create one like this. We saw this before on a couple slides ago when we were talking about variables, but that's all it is really, is you're creating a variable. So you are defining, or you're creating your type here, ball, which is the name of the class that we just wrote the slide previous, where we have our variable name here, myball. We have our assignment of value, gets, with the equal sign, and then we have our new object instance over here. So new is the keyword, then we use ball, the name of the class, and then we have the parameters for our constructor, because that's the method that's going to be called when this object instance is created. So that's how you create an object instance, and then here's how you manipulate it or call methods on it, like this. So we saw this last time, and we were a little confused, I think. So all you have to do to call a method on your instance is put your variable name down, myball, then a dot or a period. So this signifies that you're about to call a method on it. And then you have to put down the method name and any parameters that that method has. You have to actually input an actual value to give that parameter a value. So here we are, myball dot set size. So we're calling the set size method with a parameter of 30. So if you look on the previous slide, this is going to execute right here, this method. So now we've got an input of 30, and our instance variable underscore size is going to get that new value of 30. So now essentially our ball has a size of 30. Okay. So that's object instances. So that's a quick and hopefully somewhat precise overview of what we've gone over so far. So does anyone have any questions? No? Perfect understanding all around? Not quite, but maybe you don't know exactly which questions to ask? Yeah, okay.
Is that only setting the size of the ball? Like, since you didn't have anything else in there, they could set the size of the color, the bounciness.
Oh, okay. Okay, well, what it's doing, so basically all it's doing is this 30 right here is inputting 30 as the parameter to this function, or this method rather. So if you go back to the method definition, you'll see that it takes the input, or the one parameter, and uses it to assign the underscore size instance variable that value. So because it's specific to the size instance variable right here, we know that this input is going to be interpreted as the new value for the size. If this said the same exact thing, but said underscore bounciness gets new size, then you'd be changing the bounciness, and you'd probably have a bug because you probably wouldn't want to call the method which sets bounciness set size, right? Because it'd be confusing. But that's, so there's no there's no magic here. Like, it's just exactly how you say, like, exactly how you define something is going to work is how it's going to work, which is what's a little confusing, especially when you use like method names that maybe seem like there's some magic going on behind the scenes, but it's really not. It's just like you could call this method, you know, hot dog, and then right here you would say myball.hotdog30, and it would still change your size, your underscore size to 30.
Change it from 60 to 30?
Yeah, exactly. So initially, after your instance is created right here, your ball is going to have a size of 30 because it's the first parameter in your constructor. And then when this method is eventually called, that size variable will change to 30. So yeah, so it's changing from 60 to 30. Does everyone see that? Yeah. Yeah, no, it's totally fine. Whatever you want to do. Like, if you just want to change the size, then you just change the size. And then if you wanted to change the bounciness, well, first you'd actually have to write a method that would allow you to change the bounciness. So you'd have to do something very similar to this that was probably called set bounciness, and it had a parameter here, which is also an integer, and then it would say underscore bounciness gets new bounciness, and then here you could call myball.setBounciness to whatever you wanted, 5 or 6 or 0. And then that would be how you would change something else. But you don't have to change them all at the same time, or change them all, or change one of them even. It just depends on what you're trying to do.
So if you left that the way it is, it would return 30 blue 11?
So if you left this the way it was, and then you, down here, you you queried, you again wrote more methods that returned the value of the size and the color and the bounciness.
But if you just leave it, it doesn't do.
Right, yeah, it won't return anything when you leave it. It'll just keep on going, but it'll just keep on executing with whatever code you wrote down here in this theoretical class or whatever. And your ball would have those values for instance variables, but they wouldn't be like output or anything until you explicitly did that. So, yeah, that's the idea. So does everyone kind of see that? All right. So we're going to go on to something new here for a second. We're going to talk about creating random numbers. So it's somewhat often in computer science that you want to be able to create something random. You want to introduce an element of randomness to your program. Because up until now, you've only been able to manipulate values exactly, and everything's just going to happen exactly how you say. So if you want to write a program that mimics the dice roll, you're kind of screwed, right? Well, now you're no longer screwed because we're about to talk about how to do that. So there's a few different ways you can do it, but this is probably the most straightforward, although it's still a bit confusing with how they did it, but I mean, it's just how it is, so we got to learn. So here we are. This should look somewhat familiar to you. This should have the structure of creating a new object instance. So we're creating a new variable of type random, named rand, and we're giving it a new instance of this random class. And we haven't written random, right? So we don't really know exactly what it is. Well, it's actually a Java library object, or a class that Java's written for us. So we're able to use their code and use their class random, which we're going to do right now. So we've got a new variable of type random, name rand. And then down here, what we're doing is we're calling one of the methods nextInt of this random class, and we're calling it on our random instance, rand. So what this nextInt method does is it returns an integer that is a random integer between 0 and this parameter here, -1 actually. This is the confusing part. So what this does is it returns a random number between 0 and 4 basically.
Wait, where are you getting the 0 from?
Just because that's how the method works. So it's like, this is like your max value, although it can actually never be reached, so it's like non-inclusive max value. and your minimum is always 0 with how they did it. So basically, this is going to, so the value of rand int is going to be a random number between 0 and 4. And if Java wrote their stuff correctly, it should be perfectly random, and every number 0, 1, 2, 3, and 4 have an equal chance of being the value. So that's the idea. Can everyone see how that works? It's pretty good, not great, but it follows some like some of the concepts of computer science with zero-based indexing and stuff that are not that intuitive, but you just have to know. You put a 5 here, and you're going to get a number between 0 and 4. Okay.
But in the parentheses, that does not mean zero. A blank parenthesis, does that?
Right, no, that doesn't mean, so this up here,
Yeah.
so this is just because the constructor of the random class doesn't have any parameters.
Zero
Doesn't,
isn't represented.
yeah, no, 0 isn't represented here at all. It's just how they wrote their class, and they didn't, that's just what you get. Yeah,
If I put a double instead of an int before rand, would you get like,
an error.
yeah, or 2.64 rand?
Oh, okay, well, this next int method is always going to return an integer, but there's actually another method that's like, I'm not sure if it's called next double or maybe even just next, that returns a double between 0 and whatever you put here. Yeah, Joe. Like colors or something like that? Yeah, so basically, no, it's only between numbers. But then you can use those numbers to map to colors, right? So let's say you have 5 colors that you're considering, and you want to have a random color. Well, you can just basically say, if I get a 1, then it'll be red. If I get a 2, then it'll be blue. If I get a 3, then it'll be green. So you could have like a implicit mapping that allows you to essentially get a random color from a random integer. Yeah. Okay, Marissa? I'm not sure if they have methods in this class, but you could write your own if you wanted that basically. That's what's really cool is that like now you can just extend upon this class. You can, if you wanted maybe only a random even number, then you could write a method that does that for you, and then that's where you have to come up with an algorithm and figure out how to do it, and then debug it and everything. But then once you create that, then you'll have that ability, which is cool. Okay, cool. Does everyone kind of get this random business? All right, so now we're gonna. We don't have as much time as I thought we were gonna, but I want to do a little bit of a different approach and actually write some code with you guys watching and kind of asking me questions as I do it, just so you can see kind of the general workflow of how I usually do it, and then maybe that'll help you write a little bit faster or write something differently. Although this isn't necessarily the correct way to do things, it's just how I do it. And before that, I wanted to say a couple things. So we've been doing really well, like really well. I've been really impressed with you guys in lab, and everyone's been coming, and it's been really good. And this is really good. But as you're maybe learning, coding is really time consuming. Writing anything substantial takes a lot of time, and like bigger projects can take tens and hundreds of hours, and sometimes they require multiple people and all that, the whole 9 yards. And what we're doing in this class is really ambitious. We're basically doing the same type of work that would be done in an intro college class, which would meet 3 to 4 times a week and have 10 to 20 hours of homework. So basically, if you want to just see what programming is about and see how everything's working and learn if you maybe want to pursue it further, and if you want to take classes in the future, then that's totally fine. You can just come to this lecture and come to lab and do the labs, and that'll be great. But if you want to be a really prolific programmer right now, like right now as soon as possible, without taking any future classes or anything, you should probably start writing your own code, like creating your own projects that you want to do, and start doing them outside of lab and everything like that. Just because programming is this incredibly time-consuming thing that, especially when you're starting out, can take you a really long time to get any ground. So this is saying what I just said basically. So now that you've got these tools that we've learned and that we're going to continue learning about, you have the power to start writing your own things. So if you have a game that you want to make or any other project that you want to start doing, maybe you should just give it a go and start just working through it. And if you run into problems, you can email me, or you can start looking around on the internet because you have some of the terminology now. So that's the idea. Maybe if you really want to start getting good right off the bat, then it's going to take a little bit more than just coming to the lab and doing the labs. But again, if you're just trying to see if computer science is for you and see what it's all about and figure if you want to take out more classes in the future, then you can just keep on chugging along. So what comes along with that is don't be intimidated. Don't feel like you're going too slow or that everyone knows way more than you, and if you go online, there's all these things that you don't understand and that you're just never going to get it, because that's just not true. If you stick with it and you power through your problems and you ask for help when you need help, then you will get it. You will become a good programmer and you will be able to make the things that you want to make. So all you have to do is try, basically, and you have to be persistent and you have to not get frustrated. Everyone that created a really big piece of software that everyone loves or everyone uses that changed lives didn't know how to program right off the bat. They didn't just get it instantly. They had the same confusion that you're having and the same doubts that you're having. So don't be intimidated. Stick with it. So that's that. Now let's get into, we don't have a ton of time, but I'll do a little bit of what I was planning on doing. Okay. Let's see if this works. Okay, so what we're going to be writing right now, and actually in lab this week too, is kind of a game that uses the dice and allows you to gamble so that you can predict the outcome of the dice, and if you get it right, you get rewarded a certain amount of money. If you get it wrong, you get your money taken away, basically. So that's the idea. 1 sec, I got to get this monitor different. Okay. Okay. Let's see. What's out of here? All right. So, like I said, we're creating a dice game. And the way we're going to do it is we're going to create a class that models dice, and we're going to create a class that models a player. So a player in the game. And we're going to have an app class that does some like user interface stuff for us, but it's going to, what we're writing right now is going to be the main power behind the whole game. So first things first, we're going to do a new dice class. Can everyone see this? All right, yeah, okay. It's like it stands for source, basically. So that's just typically where you put like your class files. Okay. So here we are. Here's our dice class. So like I said, first step is write the declaration, and we've already got it because Eclipse did it for us. And then the second step is going to be to write some instance variables. So one property of our dice might be how many sides it has, right? You can have different sided dice, so maybe we want to have a property that models that. So we've got num size, then we've got a current value. So whatever side of the dice is up is going to be our current value. So like when you roll the dice and you get a 2, that's your current value. And then we also want to have a random number generator, basically. So the thing we just went over, we're going to have a variable that houses a new instance of that. And so this is something that I actually wanted to talk about too. So we can't use Java's code right off the bat. We need to import the library first. So the way that you do that in Eclipse is that if you have a class name right here, which is the type of your variable, and it's producing an error, you can mouse over it, and then it says, well, the first option for fixing it is import random. So that's kind of like a shortcut to doing it. But you can also just type out this import statement up here. And all this does is now it allows you to refer to the random class and use it like you would use a class that you've already written. So that's pretty cool. And so now we've got our instance variables. So what's the next step? Write the constructor, right? So this is what our constructor is going to look like. Do we want any parameters? Maybe we want to have different number of sides. Maybe you want to be able to create a dice that has 6 sides, and a dice that has 12 sides, and a dice that has however many sides you want. So we'll give that a parameter, and then we're just going to set the value of our instance variables. So we'll set num sides to the parameter. We'll set the current value to maybe 1, and we'll give the random variable a new instance of the random class. So that's the constructor. Pretty simple, right? So now we got to write some methods. So we're going to have our dice be able to roll, right? We're going to have it be able to produce a random value. So let's write a roll method. And this method is not going to return anything, so we're using the roll, or the void keyword rather. Let's call it roll like that. And I don't think it's going to need any parameters. So what are we going to do? How are we going to do this? We want to produce an int value gets random dot next int. So we're calling the next int method on our random number generator instance. And so now we have to decide our upper bound. So what's our upper bound going to be? Can anyone think about that? Right, exactly. So yeah, exactly. So yeah, you guys are thinking. So this is just like what Paul figured out. So this is going to be between 0 and our number of sides minus 1. So in order to be able to get this to numbers that you'd actually see in a dice, we should probably just do value gets value plus 1, right? So now we're going to be between, instead of being between 0 and number of sides minus 1, we're going to be between 1 and number of sides, just like a dice. So does everyone see that? And then we're going to set our current value to this new value. So now in effect we've rolled our dice. Does everyone see that? Not too complicated or anything. And then now we're going to write an accessor method. So maybe we want to be able to see how many sides this dice has. So we'll write an accessor method which is called get sides. Doesn't need any parameters. So that's what I was talking about, by the way, with the curly brace and then hitting enter. Now Eclipse has created another curly brace down here, which is pretty nice. And now I can just write inside my method really quickly. So all this is going to do is return num sides, and then I'm going to do an accessor method for the current value as well. So you can get the current value of the dice. Get value, return curval. Okay. So I think that's all we need in our dice class, but I'm not really sure. But if we need more, I'll just write it later. But does everyone see how that went? It's pretty quick. Now let's do a... Shit. This is good. All right, I'm just going to do the shortcut. Oh, shit. All right, so I'm going to do another class. It's going to model a player. It's going to be called player. And yeah, so here we are. Here's our class declaration. So first thing, write our instance variables, right? So our player is probably going to want a few properties. One of them being his balance, how much money he has. So we'll just make that a double. Oh. Let's call it balance, underscore balance. And then what else is our player going to need? He's going to need a current bet amount. So how much he's betting on the current bet. This will be another double. Can't type. And we'll call it bet amount. Pretty simple. And then we're going to need a bet value. So what he's going to be betting on the next value of the dice roll. So we need an integer that he's betting on. So bet value. And then that's basically all we need for this version of a player. So now the next step after we've declared our instance variables is going to be to write our constructor, right? So just like this. And I don't think this one is going to need any parameters. Oh. So here we are, but we do want to give them an initial balance of, I don't know, 400 or something. And then a initial bet amount of 0. And an initial bet value of 1, just so they have some value. And then we're going to need a few methods here. So we're going to need a method to set the bet amount if we want to change the bet amount. So we're going to write something called set bet amount. And that's going to set it to whatever the value of the parameter is. So we'll have double new bet. And we'll say bet amount gets new bet. Just like that. All right, I'm going really fast, and I don't think I'm going to finish either, but we'll just finish this class off, and then we can do the rest in lab. But we need a couple more methods. A set bet value, so you can set the bet value, something different. If he wants to change his bet, new bet value is the parameter, and bet value gets new bet value. Okay, cool. And then we probably just need one more method, and this is going to be the one that's kind of interesting. We're going to have a method that rolls the dice and then checks to see if he got his bet correct, and if he did, then he'll get a payment, and if he gets it wrong, then he's going to owe some money, right? Yeah, so we're going to have, so this is going to be void as well, I believe. And this is just going to be called roll dice, and this is going to take in a parameter of type dice, so we have a dice to roll, and okay, in the parameter here, like this dice and then this dice. Okay, so this is the type. This first dice. Oh, I wanted to update. Okay, so this first dice is the type. So it's like the class name, if you notice how it has a capital D. And then the second dice is our parameter variable name. So I can name this like just D or something if I wanted to, or like die might even be the, or that's the plural or whatever. But it doesn't really matter. But dice just made the most sense to me. But let's just do die, like that. Okay, so first things first, we want to actually roll our die, right? So remember we wrote our roll method in the dice. So we'll call that real quick. And now we have to do our checks. So this is, remember, an if statement. Now we have to have a Boolean in here. So we're going to do if die dot get value equals underscore bet value. So if the number he's betting on equals the number that came up on the dice, then he's going to get a nice little bonus, a payment, which we'll create here, which is going to be equal to, in order to make this fair, it's going to be the number of sides of the dice minus 1, right? This is just like a casino type thing. Times the bet. So if there's a 6-sided die and you get it right, you'll get 5 times the number that you bet, just so it's fair, right? That way you get an advantage because you're only betting on one of the numbers, which is only going to come up 1/6 of the time. So that's just in order to make the game fair. And then, is that all we need to do there? Yeah, and then we need to subtract that from his balance. So balance gets balance minus payment. Does everyone see that? And then, so if he didn't get it right, so our else clause here, our else block, will simply subtract the bet from the balance. Oh yeah, nice catch. So that would have been a bug, and you guys caught it. Perfect. Balance, right. Balance minus bet value, right? Okay, so now if he gets it right, he gets the bet value times number of sides minus 1. And if he gets it wrong, he gets his balance subtracted by the bet value. So just like you would do in real life if it was a fair game. And so yeah, that's our player class, and we ran out of time. I was going to show you how it manifested itself, but we'll see this in lab. But that's like just kind of like the workflow. So you create your new classes, you write your instance variables, then you write your constructor, and then you write your methods. And then probably you forgot a bunch of stuff while you did that, and you have to go back and change everything. But that's how you initially get everything out there after you've kind of thought of your initial design. So that's the idea. Yeah, but we'll see this more on Wednesday, and yeah, cool. All right, thanks guys. I hope you learned something from that little demo. Maybe we'll do more of that later with more time so it's not as rushed, but yeah, that's the idea. See you guys on Wednesday.
Is that gonna show up on
Yeah, that I hope that did. Yeah, so yeah, it should be still going. Yeah, so that'll show up on the screencast. Yeah, see you guys. Yeah.